All right, so let's take a look at the 8C handout, which builds on Pythag a little bit. So we already know that if we have a triangle where C is the longest side and A and B are the other two sides, then it's got to be a right triangle if A squared plus B squared equals C squared. And if A squared plus B squared doesn't equal C squared, then you know you don't have a right triangle. But it turns out that's not all you can figure out. You can figure out more detail about it if it doesn't equal C squared. So we're going to analyze that. So the first question is, what happens if you end up with it's less than C squared? So the way to think about this, that I think is the easiest way to remember this, is not to try to memorize a rule for if it's less than and greater than. Instead, it's to kind of analyze the equation. If they were equal, think of A and B as locked in numbers, right? Where you have a right triangle. A squared plus B squared equals C squared in this case, right? Whoops, not C squared. A squared plus B squared equals C squared. So then and A and B are locked in. C is a certain length that makes these things squared equal. So then the question is, what if you wanted to turn this into A squared plus B squared is less than C squared? That one of the ways you could do that is by making C longer. Right? If you made C a bigger number, then C squared would end up being bigger than the other side was. So if I left A and B the same size, but tried to make C longer, like I wanted C to get bigger somehow, and A and B are locked in to a certain length, the right angle's not. The only way that I can do that, C is bigger, so new C is longer, but the old A and B are the same, then I'd have to kind of stretch out how the A and the B are connected. And so that right angle had to get bigger as well. So this triangle, this angle is now bigger than 90. So notice this angle is now obtuse. So we have an obtuse triangle. Okay. So you can probably guess that the next one's going to be acute, but let's analyze it anyway. If you started out with a right triangle, A here, B here, C there, you know that A squared plus B squared has to equal C squared because it's a right triangle. So now the question is, what if you end up with instead A squared plus B squared isn't C squared, but it's bigger than C squared? Well, one of the ways to do this is to make the C over here get smaller. Because if C gets smaller, then C squared ends up being smaller than this side. So if C got smaller, it's no longer this long, but let's say it's only like this long, right? Well then, the way to connect your B and A, you can't just do a right angle anymore. You'd have to bend that back in, right? So you'd end up with something that looks like this instead. Here's B, here's A. Well, the right angle that used to be there became smaller. So this ends up being, well, let's say this. Our new angle is now acute. So therefore the triangle ends up being an acute triangle. An acute triangle, all the angles are acute. Okay, so the main ideas from this page, here we go. If you're linked to rules, then here are the rules. If A squared plus B squared equals C squared, you know you got a right triangle. If you ended up making C bigger, then this side is going to be, then the C squared is going to be bigger than the A squared plus B squared. And if you picture making C longer, then that's going to have to make the right angle an obtuse angle. So then you get an obtuse triangle. And if we have A squared plus B squared, but instead of equals C squared, you made C a little shorter, then you're going to end up with an acute triangle. Remember though, in all three cases, C is always the longest side. Okay. So then in number 4, the question is, are these things possible or not? Let me draw some lines in between here. So first you figure out, do you get acute, right, or obtuse if the triangle exists? Otherwise, you don't get a triangle at all. Remember, stuff like if you had, if I said, what kind of triangle do you get with sides of 1, 1, and 100? Well, if you lay down that 100 first, there's no way to connect the ones. The key here, to figure out if it exists, I'll write this on the side. To see if a triangle exists, the sum of the shorter sides has to be bigger than the longest side. And we've done some of that work before. So in each case, we'll add up the two shorter sides and see how they compare to the longer side. So let's look at A. Now, 5 root 3, 15, and 10 root 3, those aren't necessary. 15 is easy to think about. But if you're not sure about 5 root 3 and 10 root 3, let's look. 5 square root of 3 is about 8.66. So I'm just going to put here about 8.66. And 10 root 3 is going to be double that. 10 root 3 is about 17.32. So when we compare the sides, this is A, this is B, this is C. And if we do 5 root 3 plus 15, the first question is that bigger than 10 root 3? Because if it is, then the triangle exists. Yes, it is, if you actually checked it. So triangle does exist. You always got to check first, does the triangle exist? The two shorter sides definitely add up to more than the longer side. So then we're going to check them in Pythag. 5 root 3 squared plus 15 squared. And we want to know, is it equal to, is it greater than, or is it less than? Or I'll do it in the same order we did it before. Which one of these three things goes in the box when we put c squared over here, 10 root 3 all squared? So let's work it out a little bit. 5 root 3 squared. Well, you square the 5 and you square the root 3. So that's going to be 5 squared is 25, and root 3 squared is 3. So it's 25 times 3. And then 15, I'll do times there. 15 squared is 225. And then we're comparing it to 10 root 3 times 10 root 3. So it's 10 times 10 is 100. And root 3 times root 3 is 3. So we got 75 plus 225. How's that compare to 100 times 3, which is 300? Well, this is 300 on this side. So that equals 300. So all these guys are equal. Since a squared plus b squared equals c squared, we know it's a right triangle. Okay. In B, let me move this. In B, we've got 13, 21, and 35. So first, let's see if it exists. These are the two short sides. So you want to see if you add the two short sides, how does it compare to the third side? So 13 plus 21 is 34. 34 is less than 35. Well, that means that if you put down the 35 first and you try to connect the 13 and the 21, there's going to be a gap there because total, this only adds up to 34. So this triangle doesn't exist. Triangle not possible. And then for C, the two short sides are 4. We definitely know if we add 4 and 4, that's going to be bigger than 7. So the triangle does exist. Now we check what happens when we plug it into Pythag. 4 squared plus 4 squared. Let's compare that to 7 squared. Well, that's 16 plus 16 is 32. 7 squared is 49. And 49 is bigger than 32. So we get this. We got a squared plus b squared is less than c squared. So remember, if it was equal, you can go back up to the rule if you want. Remember, if it's equal to c squared, then you get a right triangle. If c squared is bigger than the rest of it, it's like you made the c bigger. And if you made the c bigger, then the a and the b are going to have to come in a little bit, and that angle becomes obtuse. So this guy is an obtuse triangle. Okay. So that's how those work. And then there's another idea that comes in down here. So find the missing side lengths of each right triangle. Okay. Well, you're only given a couple angles, but you do know 45 plus 90 is 135. That leaves this remaining angle as 45 degrees, which actually makes this an isosceles triangle. So this side's 1. This side over here is going to be 1. And then to get the remaining side, we can do Pythag. So 1 squared plus 1 squared equals c squared. So that's going to be 1 plus 1 is 2, and then we'll take the square root. So this ends up being root 2. So I want to tell you guys now, you're going to want to memorize this idea. If you have a triangle that's got angles of 45, 45, and 90, you want to know that if one side is 1, the other side is 1, and the hypotenuse is root 2. This is huge. This comes up a ton in pretty much every math class you're going to take. So, and it comes up on SATs and stuff. They'd like you to know this. So 1, 1, and root 2 for a triangle with 45, 45, 90. And the reason that it's useful, it comes up a ton just in general, but you cut a square in half, you end up with 45, 45, 90s. There's just all these different places that people use this stuff all the time. It comes in handy in architecture. Often you want, the height and the width to be the same. So then in the problems below, you'll notice there's a 90 and a 45 in each case. Well, at least in B and C. So that makes these all 45 degrees in this extra angle here. So we still got this 45, 45, 90 idea. And so what I want you to get in the habit of doing, now you can say, okay, this is 8, and then you can do Pythag to get the third side. But if you remember the fact that a 45, 45, 90 is always 1, 1, root 2, then you can set up a ratio instead, or a proportion instead. If it's 1, 1, and root 2, and this one's 8 and 8, then I'm just going to figure out, okay, this triangle here is 8 times the size of that triangle there. So 1 goes with 8 the same way that root 2 goes with this side. 1 goes with 8 the same way that root 2 goes with my missing side over here, x. If you cross multiply, you get x is 8 root 2. 8 root 2. And then you're done. Okay? So if it's 1, 1, root 2, and then you expand it to 8, well, it's 8, 8, 8 root 2. Right? So in this one, let me draw my 1, 1, root 2 triangle, but now I'm tilting it so it looks kind of the same. So 1, 1, root 2. Well, notice the root 7's like the root 1 here. So this one, instead of 1, 1, and root 2, it's going to be root 7, and root 7, root 2. Well, root 7, root 2 is root 14. So there are the other side lengths. That's the idea that I want you to get in the habit of doing. Take that 1, 1, root 2 and multiply it by whatever you need to expand it to the right size. Okay? And the last one here, well, it's isosceles and it's a right triangle, so we know these angles are the same. And if you figure out what they have to be, you end up with 45 and 45. So we got another 45, 45, 90. So let me draw my 45, 45 basic 90 triangle here. 45, 45, 90. The two congruent sides are 1, 1, and then the hypotenuse is root 2. Now notice the root 2 goes with the root 6 here. Okay, so let me call these sides x. So root 2 goes with root 6 the same way that 1 goes with x. And if I cross multiply, I've got root 2 times x is equal to root 6 times 1. And then I can divide the root 2 over. So x ends up being root 6 over root 2. And you might remember root over root, you can treat it like one big root. So that's going to be root 3. So this is root 3 and root 3. By the way, if I had done this instead, let's say I gave you the root 3 here, and you knew it was 45, 45, 90, so this one's root 3. Well, then it's 45, 45, 90, it's root 3, so it's like the 1 and the 1. And then this one would be root 3, root 2, because it's 1 times root 2 turns into root 3 times root 2, and that'll be root 6. So that's kind of a working backwards check to make sure that that works. All right, I hope that helps a little bit, and I'll see you guys soon.